I'll now introduce moving windows, a raster technique to apply a function across a raster data set. You have a window size here, a 3 by 3 window that you apply to the raster sequentially by positioning it over the first available cell and applying some function, usually some addition or multiplication or other function, to the members included in the window, and then you output the value that comes from that function into an output data layer in the corresponding cell. You then move the window over one set of cells and repeat this calculation, and you do that across the entire raster, sweeping down the rows until you get to the last cell for which the computation makes sense. That's why it's called a moving window. Now you have to define the size of the window and the function that goes with it, both those things. This window is sometimes called a kernel, and it's typically some weighted combination of the values inside that window. There's lots of functions we can do in these moving windows. These moving windows are also known as neighborhood operations, so we can calculate a mean by having an appropriate kernel, or a median, or a minimum, or a range, a slope, aspect, majority. Now note, in something like the majority or the minimum, it's not a plus, minus, multiply, divide function, but rather a more general function we apply to the members that are included in that window. But used creatively, we can do a lot of operations. The key is that we have this fixed window with that operation, and it is applied on a cell-by-cell basis to calculate a new output. You can see here, for example, in a 3 by 3 average, that for these cells here in the middle, we can lay a 3 by 3 window out. And in laying that 3 by 3 window out, then we can calculate our average value. So you can see here that these cells here correspond to this center cell, and the average we calculate gets put in the cell here in the output. And we do that back and forth then for the next set of cells, calculating the average, and the kernel is set up so that it sums these and then divides by the number of cells and then outputs that value into the output, corresponding output location. And we continue that across on a cell-by-cell basis. Now, a couple of things from that last diagram that you can see is that we have a center cell and a kernel, and this kernel is a 191919, so this moving average kernel gives us this calculation of 13/9, or so it's 1/9 times 13 plus 1/9 times 12 plus 1/9 times 11. So I'm taking the corresponding value in this cell and multiplying it, in this case, by the cell value. And so this corresponds to this multiplication. And I sum those then in this particular kernel to get the value of 11.1. Now, you have to remember that I'm just moving this window over one at a time, so the calculation for this set of cells here that goes in this location, it overlaps quite a bit with the set of cells here that I'm highlighting. There are 6 of the 9 cells in common. So we often increase the spatial covariance or autocorrelation because these two cell values in their calculations share 6 of the 9 cells. Another thing you might notice is that the cells on the edge here don't have values. It's because the kernel can't be overlain on these outside areas because you're missing cells here to calculate. This kernel doesn't make sense because you're multiplying by some undefined amount. We can fix that, and we'll talk about how to in a couple of slides. Now there's lots of things you can do. For example, here we can look at calculating a kernel. It's a difference, a horizontal difference. So it's in this case, 1 and a -1. And across this cell, this is from the book, you can see there are numbers on one side, numbers on the other that have different sizes. When they're the same, it gives you a 0 value. When they're different, it gives you what the difference is. And so you can look for abrupt breaks by this 1 -1, but that's abrupt breaks in the horizontal direction. We can do the same thing in the vertical direction, or in any direction if we put them across the diagonal. So we can look for linear features or changes in data with an appropriate kernel. There's all sorts of things that we can do. So I mentioned earlier how there's this neighborhood nibbling at the edge, and sometimes in some applications you don't want to lose data at the edge, so some folks go to the trouble of making a different kernel at the corners and along the margins so it's different from this main kernel. It has a different orientation, number of cells, different output location, and a different set of values in here inside the kernel. But this is not standard. This usually doesn't happen. Typically, what you'll do is you'll make your data area larger than the area of interest. And depending on how big your kernel is, the overlap has to be bigger. So for bigger kernels, you need a bigger area outside. And then if you pass the kernel over multiple times, you nibble away at the edge. So typically, it's just make it bigger than you'll need and apply the kernel to those data to get the output for the area that you need. So that's just a quick introduction to moving windows. There's a lot more in the book, GIS Fundamentals, on this, and we'll be applying these in labs.